Okay, so for question 9, it's all the same as far as the way you work it, but in particular, they did show you an option of just putting your information into Excel and labeling it, um, and instead of writing it on paper, just putting all your information into Excel. So I will show you how to do that. So here it says that according to a report by the government lending institution, college students who have credit cards have an average credit card balance of $1,086. So the average credit card balance. So that would be your mean of the sampling distribution. That's your mean of the hypothesis. Okay, then a random sample of 50 college students. So N is 50, so your sample size is 50. And the average credit card debt was found to be $1,389. That is your sample mean. And then let's see what your standard deviation is. Your standard deviation here is $296. So 296 is your standard deviation. Now it just wants you to, let me see if I can pull both of these up at the same time. See if I can just maybe move this over. Okay. So what we're going to do is we're going to start with an equal sign, and then we want a parenthesis to do the numerator. X bar, which is your sample mean, so 1389 minus your hypothesis mean, which is 1086. Close that. Now let's do the bottom, division, and then we want a parenthesis around the bottom, the standard deviation, that's what that stands for, 296, divided by the square root, SQRT, double click on it. We want the square root of N, which is 50, and then we need to make sure we take the square root first. So I'm going to put a parenthesis around that. And I'm not sure if that's actually necessary. We have 1, 2, 3 going this way. 1, 2, 1, 2, 3. 1, 2. I probably don't need. Let's see what happens if I just take that off. Okay, yeah, that worked. So our test statistic is 7.24. So that is correct. Now our critical z-scores for the two-tail test, where alpha is 0.01. If you go to your book, and alpha is 0.01, divided by 2 would be 0.005, which is 2.58. Let me make sure I did that right. Alpha was 0.01, so divide that by 2. So it would be 2.58. So we would have a negative 2.58 and a positive 2.58. Clearly, for a two-tailed test, if you were to draw it, 7.24 is not going to fall in between it. It's going to be way above it. So since it does not fall within the critical values, we reject it. Now, your test statistic, if you put in, try to find your p-value here of 7.24. Since it's positive, we're going to have to say 1 minus whatever we get. So if you say 1 minus what we got, it's going to be, let me say 1 minus 1 would be 0. So your p-value is 0. It's not going to happen, 7.24. So question 10, you would do the same way. This time we have 6 for our, since we already have the formula in, we could just put in 6 here for the mean of our sampling distribution. And let's see, a random sample of 50 customers. So your sample is 50. The average service was found to be 6.6 minutes. So your sample mean is 6.6. Your standard deviation, it tells you, is 1.4. So if we plug all that in there, we already have the formula. Our test statistic is going to be 3.03. And that's what we have here. Your critical value is going to be 0.01 divided by 2.005, which we already looked up previously. So negative 2.58, positive 2.58. If you were to draw that out, 3.03 is not going to fall in between those. So since it does not fall in between it, we would reject it. To get your p-value, you're going to do 3.03. And then you're going to say 1 minus 0.999. And then you're going to times that by 2 because it's a two-tailed test. And so your p-value is 0.002. So I went through that rather quickly this time. Let me know if you have any questions about those last two. You do not have to technically label it. You could just label it on paper and then plug it into your formula, plug the actual numbers in. It's up to you. But just make sure for the p-value, when you do 1 minus, you say 1 minus this rounded to 3 decimal places because it says round to 3 decimal places as needed. So that concludes this section. Let me know if you have any questions.